Hello, my name is Marco and I'm continuing my video blog about Doku. Today, I want to step a little bit back to the basics. So far, I haven't properly introduced the terminology and notation that I will be using throughout this blog. Some of this notation is de facto standard and we will recognize it from other resources. Some parts are my own choices, where I found the usual alternatives less convenient or less expressive. Before we solve more puzzles, I want us to be on the same page. So what we have here? We have a grid, also we can call it table or board. Uh, in this example, the grid has size 9 by 9, but throughout the block we will see grids of different sizes. Everything we discuss lives inside this grid. Grid consists of rows and columns. Rows are numbered from top to bottom, and the columns labeled as letters from left to right. This is the same convention you can see in Excel, Google Sheets, and other modern spreadsheet applications. When we refer to them, we write like row 5 or column G. When we see cells, also square or box, this is the smallest unit in the grid. It's the intersection of row and column. To refer to a specific cell, we use its coordinate or position, location. For example, this cell is a G5 because it's in the fifth row and column G. So we write it as G5. Some resources use different spreadsheet style notation. For example, the same cell would be R5C7, meaning fifth row and 7 column, but it's the same cell. In this log, we will always use letter number notation. Regarding cells candidates, also possible values, pencil marks, options, domain. Sometimes we need to write that we know, for example, that cell A2 has number 3, 4, or 5. We denote it so we know that there are only options we have for the cell. We write down the options. We will always write them down sorted for consistency and easier to look up. Let's talk about cages, also blocks, groups, regions. This is, as you see, they have a seeker border. Each cage has target value, like in this case 6804, and operation, which is plus, minus, multiplication, or division. In our case, it's multiplication. We denote cage as at G2, meaning that it's a cage at G2. We will always refer to the left top corner of the cage when we talk about it. Also, I want to step a little aside, talk about operations. Like as I said, we will solve puzzles with plus, minus, multiplication, and division, which is not present on my example. But what's important to say that other puzzles might have different set of operations. Some might have only plus and minus. Some might have additional operations. Also important to mention that minus and division will be present only in cages with two cells. However, I've seen also a version of the puzzle without this limitation. I want to talk about cell order within cage. When we talk about cage, I always want us to be on the same page about in which order I talk about is cells. So we always have cell traversal order or linearization or row major order. It means that we go starting from the left top corner of the cage. So it would be our the highest row, and then we go rows. We go from up to down, meaning in our case from row 3 to row 4. I'm sorry, from row 2 to row 4. And in each row we go from left to right. So in our case we start with G2, then we go to the next row, we go to F3, G3, go down, G4, H4, as we wrote it here. So this is the order, and I always want to refer to the same order without further specification. This is useful to to clearly describe, like if I say, oh, my third cell of my cage, so third cell would be this one. So we always on the same page about it. Let's talk about cage candidates. Sometimes denoting only cell candidates is not enough. We want to be more specific. So we have two notations. Ordered cage candidates, also known as fixed order or exact assignment. We know them with n-go brackets. For example, here we write it as cage G2 has in n-go brackets 1, 2, 3, 4, 5. It means that remember the cage cell order. This is 1, this is 2, this is 3, this is 4, this is 5. No other interpretations. Also, we might have unordered cage candidates when we have some values, like we see here in curly braces, 1, 2, 3, 4, 5. We know that all of these 5 numbers here, but we don't know in which order. Maybe this is 1, 3, 4, 5, 2. Maybe it's 2, 3, 5, 4, 1. Maybe any of these orders are allowed. It would be too many options to write them down as ordered candidates, so we have this option as unordered candidates. Also, we need to talk about alternatives. Often we need to say that it's one option, like we described before, or something else. So we separate them with a pipe character. Sometimes we need to talk about cell groups, like we will have two unrelated cells that don't belong to one cage, or maybe even they belong to one cage, but we want to talk about few very specific cells. So we call them cell groups, and we put them in round braces and separate with space. So, for example, in here we write this. We kind of formed our own cage, if you wish, but it doesn't represent any game object. But we still can treat it as one group and say, like we have here, that it is 1, 2 in this order, meaning that this is 1 and this is 2, or it's 3, 4. And also in angle brackets means that this is 3, this is 4, or it can be 5, 6 in curly brackets, meaning that it's in some order. Maybe it's 5, this is 6, or the other way around. Sometimes we need to talk about cage groups. Then we, instead of using cell, we put a cage. But in this case, to be clear where the cage ends, we also separate them with space. For example, like here we say cage A1. So cage A1 is this cage, and cage B2 is this cage. So this has 4 numbers, this has 3 numbers. So we can say that overall, both of them are like the following options. There's 4 options, 3 options, or there's 4 options, 3 options in unknown order, or maybe all of them are just 7 values with some unknown unknown order. Okay. And last thing I want to talk about is excluding permutations. Sometimes we don't know exact order, like we've been talking about here. We have like number 1, 2, 3, 4, 5. We don't know in which order, but maybe from some other logic, we already know that it cannot be this specific order. 1, 3, 5, 2, 4 cannot be. So it's one of these many possible permutations, but not this one and not this one. And we use them with minus sign. Okay, with this notation, and maybe later on we'll introduce something else more sophisticated as we go. But with this notation, you should be able to understand how we solve puzzles. We will be using very simple. We start with very simple puzzles, going to more and more difficult, and eventually we will have to use all of these notations. Okay, thanks for your attention. Stay tuned and to see more puzzles and their solutions. Thank you. Stay tuned.